Many of us take for granted a very extraordinary organ, our ears. To understand the ear, we need to understand what sound is. The speakers you are listening to right now are vibrating, flexing in and out, causing a wave of pressure through the air. The frequency of these waves, or the speed at which the sound creating surface moves back and forth, affects the pitch of the sound. The level of air pressure in each wave is directly related to how loud the sound is. The outer part of our ear catches these waves. It faces forward and has a specially designed structure of curves, helping us to determine the direction of the sound and also emphasize the frequencies used in human speech. Now that the sound waves are caught, they travel through the ear canal and strike against our eardrum, a thin membrane about 10 millimeters wide. Now that we receive the sound, the middle ear transfers this energy. The smallest bones in your body, the malleus, incus, and stapes, start in motion. The malleus is attached to the eardrum, and as the sound travels along, the force is amplified by leverage until it arrives at the stapes, which acts like a reversed piston, creating waves in the fluid of the inner ear. The most significant increase in pressure is caused by pneumatic amplification. The face of the stapes has a surface area of about 3.2 square millimeters, while the eardrum has a surface area of 55 square millimeters. Using this, along with leverage through the malleus and incus, the final pressure is 22 times greater than when the sound first arrived. Now we come to the most complicated part of the hearing, the cochlea. In reality, it is coiled up, but it is easier to understand straightened out. There are actually 3 chambers inside, but let's take a look at the central part. The stapes is causing pressure waves to travel through the structure. Along the inside wall is about 20 to 30,000 reed-like fibers. As the waves move along, they encounter fibers with the correct resonant frequency and energy is released. These fibers aren't actually what give us the signal that we heard something. There is a special structure next to these fibers containing hair cells. When the fibers resonate, they cause the hair cells to move, which then sends an electrical impulse to the cochlear nerve and onto the brain. Certain pitches of sound will resonate in specific locations, and louder sounds will cause more hair cells to move. Our brain interprets all this raw data, making it possible to enjoy things like music or an engaging conversation. Just to think that all of this is happening in your head right now at full speed. This is just one of the amazing systems found in the human body that go far beyond our humble human understanding.